Hello students, JEE Advanced examination is coming, and remember one thing, that the JEE Advanced question is totally different from the JEE Main question. In JEE Main, what you have done, you have solved number of PYQs and question pattern are coming common, but in JEE Advanced it is totally different type because it has tremendous analysis. Questions has having tremendous analysis with these profound calculations. Okay, and we should have total knowledge on the full chapters. Okay, so let us solve one very nice question. So in this case, it is given that limit n tend to infinity 5n c3n by 3n c2n whole to the power 1 by n equal to p to the power p by q to the power 2q, where p and q are the co-prime, and find the value of p plus q. This is the question. So how to solve this sum, everybody? First of all, we know that NCR equal to n factorial by r factorial by n minus r factorial. That we know. And if I take this as t, let t equal to limit n tend to infinity 5n c3n by 3n c2n whole to the power 1 by n. I am taking log. Obviously there is no way we have to take the log. So here, that I'll tell you one more very interesting part to solve the sum. First of all, in the first process, there are two processes to solve the sum. The first process is whatever we are doing the normal way, that is 1 by n, limit n tend to infinity. I can write limit n tend to infinity, that is 1 by n. So ln 5n c3n by 3n c2n. So this is the way, and I am calculating this portion outside. If I calculate this portion outside, so 5n c3n by 3n c2n, I can write here 5n factorial by 3n factorial and 5n minus 3n, that is 2n factorial. So 2n factorial total divided by NCR, again 3n factorial by 2n factorial into n 3n minus 2n, that is n factorial I can write. Therefore I can write here, I can cancel 2n, and if I just open this, we are getting what? 5n into 5n minus 1 into 5n minus 2 continuation 3n plus 1 divided by, I can write 3n minus 1 dot n plus 1. So this calculation, if I put in our that ln(t), in this case, in this place, if I put the calculation, what will get? I am getting ln(t) equal to limit n tend to infinity 1 by n. So I am putting here log, that is ln, what I'll put, 5n minus 1 continuation 3n plus 1 total divided by here 3n into 3n minus 1 continuation n plus 1. So everybody, this sum is very good sum, and due to the short space, I am just wiping out some part of this. Therefore I can write here this portion this portion is coming to ln(t) equal to limit n tend to infinity, and if we apply the definite integral as a limit of sum, so we are getting summation of n equal to n r, summation of r equal to 0 to 2n minus 1, because 5n to 3n, 3n to n, so 2n minus 1 log of what we are getting here, 5n minus r by 3n minus r. So we know that r by n equal to x. So integration 0 to 2, I am writing log of what? 5 minus x by 3 minus x dx. And 1 minute, I am just there is some another place I am changing here, 3x minus x. Now if I do the definite integral calculation, what we are getting, that is log t equal to 0 to 2 log of 5 minus x. By parts we have to apply integration 0 to 2 log of here 3 minus x dx. This is the integration by parts. So we have to take 1. First function is log of 5 minus x, second function is 1. And if we calculate just directly, and everybody, in this type of calculation, you have to calculate very fast and directly. So what we are getting here, log of 5 minus x minus, what will I write? That x by x minus 5 divide minus, if I write x log of 3 minus x minus integration x by x minus 3 dx, and by simple calculation, is a simple substitution method. By simple calculation, what we are getting? We are getting 5 log 5 minus 6 log 3, and if we calculate here, that is log of 5 to the power 5 by 3 to the power 6. Therefore, under this situation, it has been given that we are given that this is p to the power p by q to the power 2q. So obviously p equal to 5 and q equal to 3. Therefore, I can say here that is p equal to 5 and q equal to 3. So the answer is p plus q equal to 8. That is the final answer, everybody. Okay. So there is another very interesting method which is called the Stirling approximation. Let us discuss on this. This sum also can be solved easily by the Stirling approximation formula whenever the factorial is very big. So it is used, and Stirling approximation formula more accurately is very accurate when the factorial portion is very big. So what is telling? Let's start with the Stirling approximation formula. Let us solve the sum. So in this case, we can say that Stirling approximation formula is telling that n factorial is nearly equal to root over 2n pi into n by e whole to the power n. That is, if we take the log ln that n factorial, that is ln n minus n, very effective formula. So I am solving this sum. So in this case, log of t equal to limit n tend to infinity 1 by n, that is log 5n factorial n factorial by 3n factorial whole square, we can say. So we are using the Stirling approximation. So here Stirling approximation is telling that ln kn factorial is nearly equal to kn ln kn minus kn. So this is the Stirling approximation. So if we use this approximation, just wait, I need some space to calculate. So in this case, if we use this approximation, we are getting what? That ln t equal to limit n tend to infinity 1 by n, that is 5n ln 5 minus plus 5n ln n minus 5n plus n ln n minus n minus 6n ln 3 minus 6n ln n plus 6n. So this is the calculation, and in short we can solve the sum. Once again, what we have done, that ln kn factorial I have used kn ln kn minus kn. Similarly, that all factorial I am using, 5n factorial I am using like this, n factorial I am using this, and a denominator is there. So log a minus log n calculation. So if I just see this here, I am getting that ln t equal to limit n tend to infinity 1 by n. What is coming here? Just some values are getting cancelled. 5n ln, this is cancelled with what? n ln and 6n minus 6n ln, it is getting cancelled. Okay, and finally we are getting what? That 5n ln 5 minus 6n ln 3, and if I calculate here, That is, if I kn is getting cancelled, that is 5 ln 5 minus 6 ln 3. So that is coming to the ln 5 to the power 5 by 3 to the power 6. Therefore, we are getting t to be 5 to the power 5 by 3 to the power 6, and accordingly we are getting p equal to 5 and q equal to 3. Final answer is p plus q equal to 8. So everybody, this type of sums I'll be getting regularly, and for JEE Advanced examination, remember one thing, you have to practice so much sums with the proper analysis that you can get the total result. And just subscribe my channel and I'll just get more and more such videos. Okay, bye everyone.